Hello, everyone, and welcome to the Canadian Electricity Association's Conversation webinar series. The Canadian Electricity Association is the voice of the electricity industry in Canada. My name is Dave McKendry. I'm Senior Fellow with the CEA, and I'm pleased to be your host for today's webinar. The Conversation series features presentations from CEA's corporate partners and highlights a variety of Canadian and international solutions to current and future challenges faced by the industry. Working with CEA's corporate partners, these webinars have been developed to be of specific interest to those working in the electric utility space from generation through to the customer. For a list of upcoming sessions, please check out CEA's website at electricity.ca. These webinars allow a broad national audience to participate at no or low cost without the need to travel or invest a lot of time. We are broadcasting from Ottawa to over 40 locations across Canada today. Before we get started, here are a few housekeeping items. Our session is scheduled to run from 1 to 2 p.m. Eastern, and questions can be asked, and we would encourage you to do so as they come to mind by typing them into the chat mode on your webinar screen, and we will be asking those at the end of the presentation. We'd also ask that you please set your devices to mute. A brief survey will be sent to webinar participants following the session today, and we will very much appreciate seeing your candid feedback and are interested in any topics you would like to have included in future Conversation series webinars. Please keep an eye out for future webinars and events through CEA's monthly newsletter, Current Affairs. With over 6,000 subscribers, Current Affairs is the place to go for Canadian industry news as we connect the national value chain from generation through to the customer. If you would like to receive Current Affairs, simply go to this free publication by subscribing on CEA's website, electricity.ca. Today's topic is how COVID has impacted electrical distribution grid continuity. Our presenting corporate partner today is Hatch, and during this webinar, Hatch will outline the effects of COVID-19 on the power system across Canada. They will be exploring the impacts COVID-19 has had on select utilities and system operators across the country, challenges faced, potential opportunities to ensure the reliability and resiliency of the grid in the event of a second wave, and what to consider in a post-pandemic operating environment. Our presenters today include John Matheson. John's Senior Director, Smart Grid and Asset Management. Shivani Nathu is Smart Grid Regulatory Analyst, and Mubashir Ali is Smart Grid Specialist. John, Shivani, and Mubashir, I'll now turn this webinar over to you. Thank you.
Good afternoon, and thank you, Dave. I'd also like to thank the CEA for allowing us to give this presentation today. Through our analysis, we have discovered some interesting trends and potential risks that we're pleased to share with the CEA and its members. I'd also like to thank the utilities in different parts of the country, many of whom are CEA members, that have provided us with some feeder loading data from their systems. Some of the following analysis could not have been possible without those contributions, and we thank you. As mentioned, my name is John Matheson. I lead the Smart Grid and Asset Management team at Hatch. We help clients primarily with grid modernization, asset management, and various energy consulting services. Helping me walk through the COVID analysis and some of the impacts on the electrical grid today are two of my colleagues. As introduced, Shivani Nathu is a Smart Grid and Regulatory Analyst on the team, and Mubashir Ali is a Smart Grid Specialist. After a brief safety moment and introduction to Hatch, we will discuss the changes we have seen to system demand and typical load profiles. Then we will talk about the impacts these changes will have on asset performance and the workforce. And we will finish up talking about what challenges a second wave of COVID might bring and a few recommendations to mitigate the impacts. At Hatch, achieving no harm to people and the environment is a core value for our business. And as such, we start all of our meetings with a safety moment. As many of us have shifted to working from home, one area of risk that we might not think about is outlet safety. Home offices require many devices that need to be plugged in, your laptop, a monitor or two, a printer, perhaps you have a docking station, of course you need your phone charged, you may have a wireless headset that needs to be charged, and other pieces of equipment. And naturally, you will want all of these devices as close to your workstation as possible. And this means they're often plugged into the same outlet via a power bar. So to minimize potential safety and fire risks, here are a few safety tips to keep in mind. Always use a power bar that has a surge protector on it and that's in good condition. Don't daisy chain power cords or power bars or extension cords, and you shouldn't plug in a power bar to an extension cord either. Ensure that all power bars have good airflow around them, that they're not covered so that they don't overheat. And be sure to clean regularly around your power bars so that there isn't a buildup of dust that could cause fires. And finally, keep in mind where you are placing those power bars so that they don't also turn into potential tripping hazards. So who is Hatch? Hatch is Canada's largest private engineering consultancy. We operate across 3 core sectors: energy, metals, and infrastructure. And we also have a digital services team that we work closely with, providing services in the areas of software integration, artificial intelligence, machine learning, and some specialized optimization and app development skills. Within our energy business, our power sector focuses on 7 core areas, which include our renewables team, which is largely traditional wind and solar, our transmission and distribution team, which is where all of our power system studies and HVDC experts also reside. We have a hybrid and microgrid systems team. This is where we have expertise in energy storage and alternate vehicles, as well as hydrogen, a growing area of interest. Smart grid and asset management team, thermal power, our water or hydropower team, and our nuclear power team. The 4 teams on the left, we have combined into a team that we call our eGrid offering, which provides all of the core expertise to help our clients embrace and deliver on the energy transition. Hatch is a proud corporate partner of the Canadian Electricity Association, as well as a corporate member of the EDA in Ontario and a commercial partner of the Grid Smart City Cooperative. With over 9,000 staff in over 70 offices around the world, and about 1,200 of those that do focus on the power sector, Hatch has been delivering services to generation, transmission, and distribution utilities for nearly a century. Here, I'm not going to go through all of these, but here you see some of the aggregate sums of the sizes of projects that we have been involved with across various parts of our power business. Hatch is a global business, and we really do our best to leverage this by staying informed on best practices in other markets that we can then bring back and leverage in Canada. Examples may include being involved in very high renewable energy penetration levels and some growing green hydrogen markets within Southern Australia, the battery storage boom in California, and some of the remote power challenges that exist in Central Africa. By being involved in these markets, we can bring subject matter expertise to local challenges here in Canada. Closer to home, we do have offices from coast to coast. Our multidiscipline teams can locally partner with our clients to create unprecedented outcomes while leveraging our global expertise. Within Canada, Hatch does have experience delivering services to utilities across the country, from some of the smaller LDCs and generation IPPs to the largest vertically integrated utilities. We can leverage our coast-to-coast experience, providing right-sized offerings that meet and exceed our clients' needs. So moving into the main part of the presentation, I'd like to set the stage a little bit. The COVID-19 pandemic has led to some drastic shifts in the electricity sector, especially in the early parts of the shutdown. And these have largely been driven by businesses closing and the shift to working from home for those that have been fortunate enough to be able to work from home. These changes in turn have caused an overall bulk system demand reduction and have shifted the load curves. We have seen a shift in load from commercial and industrial more to residential, and there have been various rate relief programs implemented across the country. These factors have all resulted in generally lower revenue for utilities and CapEx and OpEx programs that have either been delayed or canceled. And we believe that many of the resultant impacts of these system utilization changes are yet to be seen. It's also important to note that when we started developing the material for this assessment, our original plan was to really focus in on just the COVID impacts. And while this is the bulk of the assessment, As you all know, we've also had some compounding weather impacts in most of the country as we've reached some record temperatures this year. So this shift to people working at home, increasing typical residential loads, and the added higher than expected air conditioning loads on those same feeders have caused some interesting results that we will discuss. This has been further compounded by the removal of some peak demand incentives like time of use, or in Ontario here, the ICI, that have caused an elimination of some incentives to reduce loads at peak times. So as we move through this presentation, you'll notice a number of these factors in the analysis. At this point, I'd like to ask Shivani to talk about some of the changes that we have seen since the COVID lockdowns began.
Thanks, John. So I'll be discussing a little bit about the bulk system changes that we've seen over the last couple of months. So one of the big changes that we've seen in April and March was really a decline in the load at the system level. This was seen all across the country, anywhere from minus 16% to a slight increase in Alberta. And as you can see from this graph, it really changes depending on jurisdiction based on the number of cases that they had at the time, what period of lockdown they were in, and just kind of what the legislation was. So if we go to look at changes in peak demand specifically, April had a huge reduction in peak demand as seen in Ontario and Nova Scotia. However, May, June, and July had increases in peak demand. And one of the reasons for this is that summer 2020 had above normal temperatures, as John mentioned. And really in Ontario, we've seen the highest demand peak that we've seen since 2013 this year in July. And that's really due, one of the reasons is because of the heat wave and, as John mentioned, the ICI freeze. If we look specifically at energy consumption, you can see a big reduction in energy consumption here in Ontario in April and May, when everything was still under lockdown, and in June, July, as places started opening up, but you still had a lot of people continuously working from home in those summer months. They're at home using their air conditioning when they otherwise would have been using their air conditioning at the office. So you kind of have an effect of double the air conditioning load on the system, which has resulted in increasing temperatures. Now, touching on the commercial and industrial side of things, many commercial and industrial customers have resumed operations now that lockdowns have been lifted, but some have filed for bankruptcy or even permanently closed. Now, when looking at industrial energy programs across the country, some of them, such as Ontario's ICI program or the industrial program in BC, consider historical demand when assigning rates and charges. However, this year, customers will have unusually low usage in March, April, and their demand may not be representative of their typical profile. Another factor that comes into play is that a lot of large customers typically adjust their usage to avoid peak charges, such as Ontario as ICI program. And so this can interfere with economic recovery impacts. If customers are more focused on avoiding peaks than getting their employees back to work, this kind of counteracts what the provinces and jurisdictions are trying to do in getting everyone back to work and getting the economy moving forward. So some of the things and the responses that we've seen is changes in the rate structure. So in Ontario, the ICI program has been frozen for this year. So customers don't really have to worry about fixing their demand or changing it to avoid peaks. And there's also been rate relief programs across the country so that commercial and industrial customers can focus on the return to work primarily. However, this results in long and short-term revenue impacts as large customers and members of this rate class really make up a huge part of where the revenue comes from for utilities as well as the system. If we look at the grid impacts, this has a resultant reduced peak shifting that's occurring naturally. As a result of the increased peaks, the capacity reserve margin has also reduced, and this is leading to some energy price increases as well as more volatility around energy prices. And one of the big things that we're seeing is that our system demand is different from what the system was designed for. So our system was originally designed for people coming into the office and doing work, but now you have people who are working from home and there's a higher residential load, lower commercial and industrial loads, and that's not really what our system is designed for. So we're yet to see what the impacts of this different load will be on the system. One of the things that the decrease in system demand in March, April, and May has done is had an effect on the excess generation. So in a lot of areas, such as Ontario, there's a lot of baseload or renewable generation, which can't necessarily be turned off and on very quickly. Our typical go-to in these situations is to export the excess electricity to neighbors. But if the neighbors are also in lockdowns and don't need that electricity, then that is no longer an option. One of the things that people would do is to lower the electricity price so that it's more appealing for our neighbors to buy electricity from us than generate it in their own space. However, that's a cost that someone has to shoulder. And another option is to start curtailing renewables. But if you have for example, a hydro plant and you're spilling water, that's going to cause environmental effects, and it also causes a loss of revenue, which someone will have to shoulder at the end of the day. So with that, I'd like to turn it over to my colleague Mubashir to discuss the changes that we've seen on the distribution feeder level.
Thanks, Shivani. I will talk about the impacts of COVID-19 on distribution system level, and I will begin by discussing the impact of COVID-19 on distribution feeder load profiles. So this slide shows the comparison of average weekday load profile of a residential distribution feeder between April to July. The top graph shows the actual loading of that feeder in megawatt. The bottom graph shows the average outside temperature. So 2019 data is shown with the dotted line, while 2020 profiles are represented with solid curve. On the x-axis, we have hours of the day. As we can see, the distribution feeder load profile shows an increase in residential demand and peak load, which is mainly driven by shift in behaviors, such as people staying at home, remote working, and also it is worth noting that especially in the month of June and July, we see a significant increase in demand, which could be attributed to increase in the usage of thermostatic load, especially air conditioning load. So overall, we are seeing an increase in energy demand, and as well as the peak on the residential feeders. So this slide is building on the previous slide, comparing 2019 load profiles versus 2020 load profiles of different distribution circuit across Canada. So we observed a similar trend across different parts of Canada. On this graph, we are showing a feeder from a Toronto area, another feeder from Toronto area, and then a southern Western Ontario, and also a feeder from Atlantic. And it is evident the impact of COVID-19 on a residential feeder load profile, suggesting that there is an increase in the residential demand and peak load across different distribution systems of Canada. So in addition to changes in peak demand, the temporal pattern have also shifted. So we investigated that, and the graph on the screen shows a comparison of average weekday load profile of 2019 versus 2020 months. Here, the loading values of the feeder are normalized to the peak load in order to show a clear comparison between the same months, which is say, April, May, and June. So as we can see, the changes in load shape are consistent with the people starting the day later. We're seeing higher midday loads due to the increased occupancy and people working from home and staying at home in general. And also we see less steep evening ramp compared to the norm. During the evening hours and nighttime, we see as anticipated, we see a typical pattern. So this shows that not only the magnitude of the loading, but also the load shape has changed quite a bit due to the COVID on a residential feeders. So we analyze the feeder data on a deeper level and quantify the sort of a correlation between the new load shape versus the norm to see how much it has been impacted by COVID. So on the screen, this graph, the blue bubble basically represents the correlation between the weekday load profile, and the white ones represent the weekend correlations, sort of comparing the two similar days. On the x-axis, we have the week of the period we analyze from the month of Feb to July. So as we can see, the correlation of weekday load profiles starting for the month of Feb and early May was very strong, but then it's deviated sharply from mid-March and continues throughout the month of June and even mid-July due to the impact of COVID-19 that we discussed. So, however, in July 2020, as we saw things easing up especially in in the province of Ontario, GTA area, so the profile sort of returning to the pre-COVID normal. As for the weekend load shape, as anticipated, there were no impacts as such, and the profiles were roughly the same compared to the business as usual. So what are some implications due to this change in feeder demand on distribution level? So this extensive teleworking, remote working has already led to increase in demand, and we believe it would continue for the remainder of the year and possibly the following years. So there will be an adverse effect on, because of that, there will be an adverse effect on utilities operational efficiency and in general distribution asset performance management. We see that utilities are facing revenue challenges as they have to provide service to even non-paying customers due to government directives. In addition, it may also have impacts on the future rate because of the economic situation. The effects may last longer, so many customers will not support the resultant increase in rates, which would eventually be difficult for LDCs to have better rates in the future. So this next section covers the impact of COVID-19 on asset performance. So effect of new load profile on distribution transformers. So distribution transformers, service transformers is a critical asset class on a T&D system. And the reason is they're not normally designed for N-1 reliability requirements compared to the upper stream assets such as feeders, substation transformers, and they're also vulnerable to loading magnitude and pattern. So because of this new load shape that has a higher peak and also wider peak, and now as it is imposed on the distribution transformer, it will have some significant impact on the insulation, which will eventually increase the accelerated loss of life or aging. So this could eventually lead to some normal failures or even catastrophic failures, which could have high safety and reliability cost to utilities. One of the specific challenges the utilities are going to face due to the changes in demand pattern on a distribution system level is going to be the distribution system planning. As we know that load forecasting is the foundation of system planning and expansion. And now traditional forecasting methods are constructed and validated on historical events, data, including the weather data, which is always the important variable. But now with this sudden change in the demand patterns or the load shape, now it is going to cause difficulty in load forecasting, especially in the short term, given we don't have any similar event like COVID in the past. So for utilities, it is going to be difficult to construct some robust planning algorithm or planning model because of this uncertainty. To add to this complexity is the workforce disruption, which is utilities facing. So it will not also help the situation. And also the OEB has forgone the revenue rate rider model for postponed rates, which also not help the situation as such for the utilities. So COVID-19 has also impacted the utility capital projects. We learned from many utilities that they have dialed down their capital projects, especially small to medium-sized utilities, and the focus has been more on keeping the lights on, providing the services to the to the customers or critical customers. So they have delayed or paused any major system implementation projects, and they're not taking anything new in terms of any capital projects. Now, this could have mid to long-term reliability impacts, especially for utilities, and there is a risk that the reliability targets won't be met. And this, especially for the utilities that have aging asset base and are not as far along the data-driven asset management maturity curve, could be facing more challenges compared to the utilities that are relying on data-driven asset management. So, impact of COVID-19 on utilities operation. So talking to some utilities, we learned that since COVID-19, they reverted to daily focus on keeping the operations going, maintenance and activities, and other refurbishment programs have been deferred. Also, during the first few months of pandemic, there were some challenges in making remote working arrangements for many of their office staff, and to account for the social distancing, organizing multiple reporting sites for the field operations team also was a challenge for the utilities. In addition, the longer time now required for crew dispatching, fault investigation, and switching, especially for utilities that do not have distribution automation or grid automation in place, would be a challenge. And it is worth mentioning that now residential sector and healthcare sector has made distribution grid even more critical. So the second wave may pose some additional operational and reliability challenges to utilities operation. So at this point, I would like to hand it over to Shivani to discuss the impact on workforce.
Thanks, Mubashir. So looking at the workforce in the power sector specifically, many of us know the power sector has an aging workforce. So many members of the workforce can be high risk for COVID-19. There's a lot of workforce disruption due to illness and quarantine, as Mubashir mentioned. And another challenge that we may be facing and seeing within the next year or so is that some older workers may just take this time to retire early to avoid a lot of these risks. Now, with new workers coming on board, it's hard to train new workers remotely, specifically those who would typically be in the office, so the engineering teams, customer relations, those types of jobs. And another challenge that utilities are facing is that some of them don't have the money to hire new graduates. However, if new graduates aren't able to get a job in the power sector, they may switch to another field, which will reduce the future workforce pool that utilities can pull from. Work transfers to crews, as Mubashir mentioned, is difficult to do in person because of social distancing, and work crew platooning may also result in less flexibility in schedule. If the different work crews have different skill sets, then you may not be able to get all the work done when you need to, or in the time that is needed. So I guess the big question that everyone's asking is, what's next? So if we have a second wave, and for many people, it's not a question of if, but it's a question of when we have a second wave, this will compound the issues that we're already seeing. We'll see a similar increased residential demand, especially in areas that are winter peaking or have a lot of electric heating. This summer, we've seen a lot of excess demand on the residential side because of air conditioning loads. And so in the winter, we're expecting to see a similar trend because of residential heating loads that are electric. There's also new guidelines that ASHRAE has put out in terms of bringing back commercial and industrial spaces, and they recommend increasing HVAC usage regardless of occupancy to really make the areas safe for customers and people in those spaces. And so that will also have an effect of increasing the demand. On the other side of things, businesses are at risk of permanent closure. The CFIB had said back in June that 14% of Canadian small businesses were at risk of permanently closing due to COVID. And if we have a second wave, that number will increase. There would also be continued reduced demand in the commercial and industrial sector due to shutdowns. And again, with the second hit, we don't know how many of those businesses will permanently go out of business. And again, further maintenance delays and operational changes to protect the health of utility workers. beyond the second wave and looking at the mid to long term, either in a post-COVID world or in 5 to 10 years' time with COVID still around, there's another set of challenges. So there may be a permanent potential loss of demand from commercial industrial customers if they're unable to recover. This will create more challenges for utility in that there may be revenue challenges moving forward if smaller utilities are relying on those commercial industrial customers for a large portion of their revenue, but they're no longer around. Where are we going to get the money from? There'll also be unprecedented operational challenges and network management issues from running our grid for so long in a way that it wasn't designed to run. As Mubashir mentioned, there's a lot of load forecasting uncertainties. There's potential long-term load increase in residential and decrease in commercial from permanent remote work. We also don't know how many of these office spaces will recover, how many people will go back into the offices opposed to just working from home, and how many businesses will close. And there's also locational changes. So if people decide to leave the city because they don't need to work in the office before, that could cause an impact. And finally, a gap in workforce. As mentioned, if we're not getting new graduates and junior employees into the field now, we may have a shortage of mid-career employees to pull from in 5 or 10 years' time. So what are some mitigations to that? One of the big things is embracing a digital workspace. So really focusing on changing workflows from historic paper and just doing what we needed to get done up until this point to optimizing how we can work from home and allowing more work from home, optimizing workflows, and also reducing the number of people in our office, which can help with COVID-19 alignment in terms of social distancing, but also save money because you'd need to lease less commercial space. Now I'll hand it off to Mubashir to talk about CapEx and OpEx planning.
Thanks, Shivani. Yeah, one of the possible mitigation would be doing a CapEx, OpEx investment planning. As we see in the previous slides, the demand pattern, both on the residential and system level, has changed. So utilities should perform some system impact studies to assess assess any pocket or area loading, and see if there are some opportunities for grid reconfiguration. Also leveraging asset data to make revised capital and maintenance decisions. One of the other things that could be helpful is doing a capacity management, doing so by performing optimization across it to optimize the asset utilization, to defer any capital investment, which will help them in increase reliability. Last but not the least is investing in grid modernization to defer any upgrades on a specific T&D node, or making the network more smart by deploying distribution automation on worst performing feeders will also help them to mitigate some of the impacts. So supply chain, or MRO, which is maintenance, repair and operations parts supply. So utilities could assess the impact that COVID has had on the availability of parts and warehouse operation to streamline that. Also, it's a good opportunity to reevaluate spares and contingency plan, and also review parts harmonization and standardization to mitigate some of the impacts, and which would also help them to cover that revenue loss in the longer term, and also increase the efficiency. Also, one of the area is free field crew utilization. So utilities could optimize the outage workflow to reduce the customer minutes out and the total cost of ownership in the long run. Because as the major capital projects are deferred or paused, so the field crew workers could also perform some asset condition assessment in the meanwhile, or target those assets that require some maintenance to increase the lifetime of those assets and reducing the total cost of ownership in the long run. And also in general assessing the impact that physical distancing, we talked about managing, the utilities are managing different sites. So what that could have on the work group performance would also help them to mitigate some of the issues. So thank you so much.
So that concludes our presentation. I welcome any questions at this point.
Well, thank you very much, John and Shivani and Mubashir. It's a very broad-reaching topic that you've been addressing, and we appreciate your perspective. You know, we heard some very interesting things. We heard about AC load going up because in addition to the regular commercial AC that would be going on, there's more going on in the residential section. We heard that the system demand now is different from the design case. What to do with that excess electricity now that there's capacity, but we can't dump it because there are other jurisdictions that are facing the same challenges. We heard about increased consumption on the grid could shorten asset life. We heard that LDCs are scaling back their capital work, and that on the workforce side of the equation, we've got accelerated retirements. It's hard to train new workers remotely. There's work crew platooning challenges. And then there's the whole what's next? What if second wave, and Shivani, to your point, it's not necessarily if, but when, second wave. And what are the short-term impacts? What are the mid and longer range impacts? And we certainly appreciated both Shivani and Mubashir, the mitigation recommendations that you're putting forward. A lot of information there. In terms of our viewers, your opportunity now to ask your questions, and to do so, you simply go into your webinar question site. You can see on the screen here. Just tap in your question, and we'll get that handled. We do have some questions that have come in to our presenters, and I guess the first one is, what are the estimated impacts, if they can be quantified, by large businesses that are tenant space, and they're potentially moving to virtual? For example, in Ottawa, Shopify has declared that, you know, they're basically everybody's going to basically work from home. That's a scary thought. What are the impacts of that, and if it really starts to go? Any thoughts on that, Brent?
I think I can take a stab at that one. So the impacts of it really, there's kind of two types of things. As one of them is that, you know, a lot of our systems, not only electricity systems, but you look at commuter systems, the transit, all of these different aspects are really designed to get commuters into the city so that they can work. So you'll see a lot of stranded assets, in many spaces, you know, empty office buildings. A lot of realty companies don't really know what to do with their commercial office space because no one wants to lease long term at the moment. You may see stranded assets on the distribution side of things where these transformers aren't getting used to the level that they were expected to. And even stranded assets in the transit system, you know, ridership going down, and you don't know what to do with all of these different investments. So I think it's a question that a lot of people have, and we're not really sure what the effects would be. I was reading something in the New York Times that they still expect people to eventually return to New York just because of the way that the system and the city is. And so I think in the long term, a lot of people are expecting people to come back to cities and use those spaces anyways. It's just a question of when that will be.
Great, thank you. Another question come in. Even though there's been a shift of consumption, has the grid held up? Have there been any issues handling the additional residential load, or have you seen spots where there has been failure? We heard about the opportunity for advanced failure or end of life. Have we seen that yet, or is that still a curve we're about to hit?
So maybe I could take this one. So I think at this point it's difficult to tell, but I think one thing is clear. We see on a distribution level, because of this new load profile that has higher peak, and not just higher peak, but also we are seeing a temporal shift in the demand on the feeder loading. So when they would be imposed on distribution assets, such as transformers, cables, or conductors. So certainly it would have some deteriorating impacts on the insulation of transformers or other assets like cable. So it's it's a little bit difficult to predict, but especially for utilities that have higher aging asset base, they could anticipate increased number of failures, resulting in some unplanned outages, and they would have some increased cost of reliability then in the longer run.
Right, yeah, that makes sense. Thank you. Just a reminder, if you've got a question, please tap it into the screen and we'll get your question. Shivani, maybe we'll go to the next one to you. What are some of the long-term changes we may see in the commercial and industrial sectors as a result of COVID?
So I think one of the ones was what we had touched on earlier about people not returning to offices, so having empty industrial or empty commercial spaces. One thing that we may
She's left us on a cliffhanger.
Yeah, maybe we've got freezing there. John or Mubashir, might you be able to take a shot at that? What are the implications on distribution assets if the recent changes to loads were to persist?
Sure. So if this sort of impacts of COVID persist and this behavior continues with the varying level of degree of remote working and people staying at home, which is a little bit uncertain at this point. So it could, as I mentioned earlier, it would have significant impacts on the distribution assets. So it will deteriorate the assets, especially the distribution assets like service transformers. It will deteriorate its insulation. The hotspot temperature is going to go high, and which eventually would result in increased number of normal or catastrophic failure that is going to cost the utilities in terms of financial reliability, safety, or even environmental cost because of oil leakages or spillage. So yeah, this would have some serious impacts if this continues for a longer period of time.
Great, thank you. Sorry, Shivani, we lost you for just a moment. Thank you for jumping back. So Mubashir helped with the question that we were asking there. And maybe John, we'll just go to you on this one. How do you see electrification further impacting the load changes we're seeing now?
Well, there's a couple of pieces to that. The biggest electrification element that is talked about is around transportation, and largely through EVs, or even in certain jurisdictions, the electrification of rail. As EVs penetrate residential feeders more and more, there will be additional capacity and voltage challenges on those feeders. In the current environment, I suppose there's a balance of people that may not be going out to buy new cars if they're largely working from home at the moment, so there's a bit of a balance there. But as things do return to some kind of greater normal, some of the impacts on the distribution assets that Mubashir has mentioned that may be reducing life in the medium to longer term can be compounded by the increasing load that EVs may have on the distribution feeders.
Great, no, thank you very much. Well, we've come to the end of our questions here, and just the last opportunity. If viewers wanted to ask a question, please don't hesitate to do so. And as people are considering that, I would like to thank each of you, John and Mubashir and Shivani, for taking the time to share with us more about Hatch. The work that you do, not only from a Canadian perspective, but internationally. And thank you for sharing your perspectives in terms of the impacts of COVID on the grid. With that, I would invite you to, you can go off camera at this point in time, and we'll just do a wrap up here. So also just wanted to let you know to mark your calendars. Our next conversation series webinars will be held on September the 17th. Oracle Utilities will be presenting electric utilities post-COVID, and what's next and how should utilities respond. And then on September 22nd, Lexop will be presenting how meeting consumer preferences can help you adapt during a downturn. And if you haven't yet registered, you can do so by going to CEA's website at electricity.ca. So in closing, I would like to once again thank John, Shivani, and Mubashir, and each of you for joining us today. This concludes today's conversation series webinar, and we'll talk to you next time. Bye for now.